Hello, my name is Daniel, and today I'm going to be going over the BC FRQ from 2011, number 3. It's a question about arc lengths, and it also has some related rates in it. So, without further ado, let's jump straight in. Let f of x equal e to the 2x, and R be the region in the first quadrant bounded by the graph of f and the coordinate axes, and the vertical line x equals k, where k is greater than 0. The region R is shown. Part A asks you to write but not evaluate the expression involving an integral that gives the perimeter of R in terms of k. So one tricky part with part A is it's asking you to write the perimeter, not just the length of the arc. So you're going to have to not only calculate this length, but also add these lengths as well. So perimeter, we know, is going to be the length around the edge of the region. So perimeter P is going to be this length, which is 1, plus this length, k, plus this length, which is e to the 2k, sorry. And finally, plus this length. And this is an arc, and the length of an arc is given by the formula it's going to be the integral from the starting x value to the ending x value of the square root of 1 plus the derivative of the function squared with respect to x. So let's evaluate. Since we don't have to evaluate this for this question, it says do not evaluate, we can just go ahead and write this. So the starting x value is 0, the ending x value is k in this case, square root of 1 plus dy dx squared. Dy dx is the derivative of f of x. The derivative of e to the 2x is you just bring down the 2, and e to the 2x remains how it is. And of course that's squared dx. There you go. That is part A. If you do not know the formula for the length of an arc, there really is no way to get any sort of partial credit. So sorry about that. I guess you ran out of luck there. Part B says the region is rotated about the x-axis to form a solid. Find the volume V of the solid in terms of K. So this region is being rotated around the x-axis. That means that the volume of the rotated figure is going to be the sums of each of these areas formed by the circles here. So we can express that infinite sum as an integral. So we know that volume is the integral of area. Well, the area is pi r squared because these are all circles when they revolve around the x-axis. If you imagine a line segment being revolved around the x-axis, is going to form a circle. And this one's particularly nice because all of these segments end on the x-axis, so we're not going to have to subtract anything in the middle. So really this is just the integral, pi times the integral of the radius squared. The radius is just going to be the value of the function at that point. For example, here the radius would be e to the 2k, since that's the distance from that point to the x-axis. So we can just say f of x squared. And this integral is going to be from the starting x value to the ending x value, or from 0 to k. So that is our form for the volume. Now we need to evaluate it. This is pi times integral 0 to k f of x squared is e to the 4x. And the integral of e to the 4x is going to be e to the 4x over 4. And we're evaluating this from 0 to k. So plugging in k and 0, we get that this is pi over 4 times e to the 4k minus pi over 4 times e to the 0, or just times 1. So that's our final answer, pi over 4 e to the 4k minus pi over 4. If you did not know how to do this type of problem, you could actually get some partial credit. For example, if you knew that volume was the integral of the area and you knew the formula, you could have written this and possibly gotten 1 point. If you knew to plug in the value for the function as r, then that would have also gotten you 1 point. So even if you messed up in your computation, you could have gotten some partial credit on this one. Finally, for part C, it asks us the volume found in part B changes as k changes, So if dk over dt is 1 over 3, determine dv over dt when k is 1/2. Well, we know volume from part B is pi over 4, sorry, this is part C, pi over 4 e to the 4k minus pi over 4. So the derivative with respect to t of both sides is going to give dv over dt equals pi over 4 e to the 4k times 4 dk over dt minus the derivative of a constant is always 0. And now we are given in the problem statement that dk over dt is 1/3 and k is 1/2. So let's plug that in. dv over dt equals pi over 4 e to the 4 times 1/2 times 4 times 1/3. So now we can go ahead and cancel this, and we're left with pi over 3 times e squared. So that's going to be the rate of change of the volume. If you want to be fancy, you can go ahead and write units cubed per unit of time, so probably second. And yeah, that's how you do this problem. If you did not know how to substitute in related rates, unfortunately, there was not a way for you to get partial credit. So sorry about that. If you have any other questions about related rates or arc length, you can consult other BC FRQ problems that will be in the description, that will be linked in the description below from our other classmates. So thank you for listening, and I hope you learned something today.